For centuries, the moon has hung in our night sky, a silent, luminous companion, watching over humanity's triumphs and struggles. We've walked its surface, mapped its craters, and even brought pieces of it back to Earth. Yet, despite all our advancements, the moon still guards secrets that defy explanation. Strange structures, unexplained lights, and geometric anomalies spotted by astronauts and telescopes alike continue to puzzle scientists. What if the moon isn't the barren, lifeless rock we've always assumed it to be? Think about it. We live in an age where technology can peer into the depths of space, uncovering the birth of galaxies billions of light years away. But right there, just 238,000 miles from Earth, our closest celestial neighbor holds mysteries that challenge everything we think we know. From towering spires that cast impossible shadows to eerie, transient lunar phenomena, flashes of light with no clear source, the moon seems to whisper riddles we're only beginning to hear. And the deeper we look, the more questions arise. Why do some craters appear artificially aligned? What could explain the bizarre, perfectly symmetrical domes spotted in high-resolution images? This isn't just about curiosity, it's about rewriting history. Each unexplained anomaly we uncover forces us to reconsider what we've been told. Could there be more to the moon's story than meets the eye? Today, we're diving into 25 of the most baffling lunar anomalies ever documented, phenomena that even NASA struggles to explain. Some may be natural oddities, tricks of light and shadow. But others, they defy logic entirely. So buckle up. By the time we're done, you'll never look at the moon the same way again. The moon has been flickering like a cosmic light bulb for centuries. Unpredictable bursts of light, sudden color shifts, and fleeting glows that appear and vanish without warning. These aren't just modern observations. Even in the late 1500s, the astronomer William Herschel reported seeing red-tinted flashes near the crater Aristarchus, convinced he was witnessing lunar volcanoes. Fast forward to the Apollo era, and astronauts orbiting the moon radioed back accounts of strange, pulsing lights in regions like the dark side of the Mare Crisium. NASA catalogued hundreds of these events under the label Lunar Transient Phenomena, or LTP, but to this day, no one can say for certain what's causing them. Some scientists point to outgassing pockets of trapped radon or helium bubbling up from beneath the surface, releasing energy as they burst into the vacuum of space. Others argue it's the result of meteoroids slamming into the moon at staggering speeds, creating brief but brilliant impact flares. But here's the twist: many LTPs occur in the same locations repeatedly, like cosmic hotspots. The crater Plateau, for example, has been a stage for these flickers for decades, with some flashes lasting hours, far longer than any meteor strike could explain. Even stranger, some LTPs seem to follow geometric patterns or cluster in ways that defy random chance. Then there's the enigma of the dark LTPs, shadowy patches that appear to creep across the lunar surface, dimming entire regions before fading away. Ancient astronomers described these as veils obscuring the moon's face, but modern telescopes have caught them in action. Could these be clouds of lunar dust, electrically charged and levitating above the surface? Or something even more unexpected? The truth is, every time we think we've pinned down an explanation, the moon throws another curveball. It's as if our closest neighbor is playing a cosmic game of peekaboo, daring us to look closer, to question deeper. And with each unexplained flash, the mystery only grows. Among the moon's many enigmas, few are as visually striking or as fiercely debated as the so-called shard and tower. These bizarre formations, captured in images from lunar orbiters, rise defiantly from the barren landscape, some appearing to stretch thousands of feet into the black sky. Their jagged silhouettes and impossible angles have fueled speculation for decades. Could these be remnants of some ancient alien architecture, or simply the tricks of light and shadow playing on the moon's rugged terrain? The shard, first spotted in a lunar orbiter images from the 1960s, looms like a shattered skyscraper near the crater Euclid. Its angular, almost sculpted edges stand in stark contrast to the surrounding rubble, a geometric anomaly in a world shaped by chaos. Some researchers argue the structure's precise angles and towering height defy natural explanations. Lunar geologists counter that it could be an unusually sharp outcrop of basalt, fractured over eons by meteor impacts and thermal stress. Yet even they admit, nature rarely produces such clean, linear fractures at this scale. Then there's the tower, a needle-like spire photographed near the Mare Crisium, estimated to soar over 5 miles high. That's taller than Mount Everest stood on its base. Its shadow, cast across the lunar surface at a low angle, reveals a thin, impossibly elongated form that seems to defy the moon's weak gravity. Critics dismiss it as a lens artifact or a trick of perspective, pointing to similar towers in Apollo mission images later debunked as camera malfunctions. But here's the catch: some of these structures reappear in multiple images taken years apart by different orbiters. If it were just a glitch, why would it persist across missions? The debate takes a stranger turn when you examine the positioning. Both the shard and the tower appear near regions rich in transient lunar phenomena, those unexplained flashes of light we just discussed. Coincidence, or could there be a connection? A few theorists go further, suggesting these formations might be remnants of some long-lost lunar infrastructure, perhaps even energy collectors or observatories built by a civilization lost to time. Mainstream science scoffs at the idea, but even skeptics struggle to explain how natural processes alone could create such eerily symmetrical shapes. The truth might lie somewhere in between. The moon is a place of extremes, brutal temperature swings, relentless micrometeorite bombardment, and electrostatic forces that can make dust cling like glue. Under those conditions, maybe geology behaves in ways we don't yet understand. Or maybe, just maybe, we're glimpsing something that challenges not just our knowledge of the moon but our place in the cosmos. Either way, these silent sentinels aren't giving up their secrets easily. Among the moon's most perplexing sights are the Blair Cuspids, a cluster of towering, needle-like formations jutting from the lunar surface like the jagged teeth of some colossal beast. First photographed by a Lunar Orbiter 2 in 1966, these bizarre spires rise near the crater Gambart, casting long, ominous shadows that stretch for miles across the dusty plains. What makes them remarkable isn't just their height, some estimated at over 150 feet tall, but their uncanny uniformity. Arranged in a near-perfect geometric pattern, they resemble the ruined pillars of a forgotten temple rather than random geological formations. Lunar geologists argue the Cuspids could be the result of extreme volcanic activity from the moon's turbulent past, ancient magma conduits that cooled into hardened basalt spires, exposed over eons as softer rock eroded away. It's a plausible explanation except for one nagging detail. Natural erosion on the moon happens at a glacial pace. Meteoroid impacts scatter debris randomly, yet the Cuspids stand in eerily precise alignment, as if placed there deliberately. Even stranger, their shadows reveal edges so sharp they look almost machined, something rarely seen in lunar geology, where eons of micrometeorite bombardment typically round off every surface. Then there's the timing. The lunar orbiter's images were taken just 3 years before Apollo 11's historic landing, yet NASA never publicly flagged the Cuspids as a point of interest for astronauts to investigate. Conspiracy theorists pounce on this omission, suggesting the agency quietly avoided the area. Skeptics counter that with hundreds of unusual formations dotting the moon, prioritizing one cluster over another meant little. But the silence only deepened the mystery. Years later, independent researchers studying the original images noticed something even more unsettling, a subtle but deliberate blurring of the Cuspids in some archived photos, as if someone had tried to obscure their details. Official explanations cite camera glitches or film degradation, but for believers it reeks of a cover-up. Could these spires be the remnants of some ancient lunar civilization, their purpose lost to time? Or are we seeing an extraordinary but entirely natural phenomenon that challenges our understanding of lunar geology? The debate rages on, with neither side holding definitive proof. What's undeniable is that the Blair Cuspids defy easy explanation. They stand as silent sentinels, daring us to unravel their secrets if we're bold enough to look closer. High above the moon's ancient plains, stretching between two crater rims like an architectural relic from another age, lies one of the most hotly debated anomalies in lunar history, the so-called Lunar Bridge. First identified in images from the 1950s, this peculiar formation appears to arch gracefully over the surface, connecting high points in the region known as the Mare Crisium with a structure that defies conventional explanations. At first glance, it looks like the remnants of a colossal stone viaduct, a bridge built by no human hands. But is this a trick of perspective, a freak of lunar geology, or evidence of something far stranger? The bridge's most famous photograph came from the archives of the British Astronomical Association, captured through a telescope in 1953. The image shows what appears to be a slender, curved span roughly 3 miles long, suspended hundreds of feet above the lunar surface. Skeptics were quick to dismiss it as a clever interplay of light and shadow, a rare alignment where the sun's angle turned a serrated ridge into the illusion of an arch. Yet when later missions like NAS, a lunar reconnaissance orbiter, trained their high-resolution cameras on the same area, something curious emerged. While most of the bridge faded under scrutiny, portions of the structure retained an unusual, almost geometric clarity. Lunar geologists propose an alternative theory. This could be the remnants of a collapsed lava tube. The moon's volcanic past left behind vast networks of hollow tunnels, and when sections of these tubes cave in, they sometimes leave behind arched sections that mimic artificial structures. But here's the problem: lava tubes typically collapse chaotically, leaving jagged debris fields. The Lunar Bridge, by contrast, appears startlingly symmetrical, with a curvature that seems too precise for random geology. Even more puzzling, a few researchers claim to have detected a repeating pattern in the structure's shadows, something resembling support like pillars along its length. Then there's the historical context. Ancient astronaut theorists point to a controversial passage from the Soviet newspaper Vechny Leningrad in the 1960s, where astronomer Nikolai Kozyrev allegedly speculated about possible artificial structures in the Mare Crisium region. Mainstream science dismisses this as sensationalism, but the whispers persist. Could the bridge be a remnant of some ancient lunar civilization, or even an extraterrestrial outpost? Though wilder theories suggest it might be part of a transportation network, an idea straight out of science fiction, yet the simplest explanation might still be the most compelling. The human brain is wired to see patterns, especially familiar shapes like bridges or arches, in random formations. Pareidolia, the phenomenon that makes us see faces in clouds or animals in rock formations, could be at work here. Combine that with the moon's harsh lighting, where the lack of atmosphere creates razor-sharp contrasts between light and shadow, and suddenly, an ordinary ridge transforms into something extraordinary. So where does that leave us? The Lunar Bridge exists in a tantalizing gray area, too strange to ignore, yet too ambiguous to confirm. Whether it's a geological oddity or something more profound, it forces us to question how much we truly understand about the moon's past. Every unexplainable structure, every fleeting shadow chips away at our assumptions, and perhaps that's the real mystery, not just what's up there, but why we're so determined to find answers in the first place. Deep within the vast, sun-scorched expanse of Tycho crater, one of the moon's most prominent and youthful impact sites, rests an anomaly that sparked debate for decades. The Tycho Pyramid, as it's come to be known, juts from the crater's rugged floor with geometric precision. its four sloping sides mirroring the iconic shape of Earth's ancient pyramids. First highlighted in NASA's Lunar Reconnaissance Orbiter images, this structure stands apart from the surrounding chaos of impact debris, its sharp angles and symmetrical base appearing almost deliberately crafted. At roughly 150 feet wide and half as tall, the pyramid's dimensions aren't colossal, but its implications could be. Mainstream planetary scientists argue it's a textbook example of a central peak, a common feature in large impact craters where the ground rebounds after a meteor strike, thrusting material upward in a jagged spire. Over time, erosion from micrometeorites could theoretically sculpt such a peak into a pyramidal form. But critics note a key discrepancy. Central peaks are typically irregular, shattered by the very forces that created them. The Tycho Pyramid, by contrast, displays unsettling symmetry with edges that appear unnaturally straight when magnified. Then there's the placement. The pyramid sits near the convergence of several linear grooves, sinuous rills that some researchers suggest could be remnants of ancient lava channels. But others point out these grooves align with the pyramid's base at near-perfect right angles, a configuration rarely seen in natural geology. Even more curious, thermal imaging reveals the structure cools at a different rate than surrounding rock, hinting at possible differences in composition or density. Theories about artificial origins range from the sober to the spectacular. Some researchers propose the pyramid could be the eroded remnant of a lunar outpost built by an ancient civilization, human or otherwise, that once sought refuge or resources on the moon. More speculative voices suggest it might function as a beacon or energy transmitter, given its position catching sunlight at precise angles during lunar dawn. Skeptics counter that pareidolia, the human tendency to see familiar shapes in random patterns, is at work, amplified by the moon's harsh lighting. Yet the debate intensifies when comparing the Tycho Pyramid to terrestrial counterparts. The angles of its slopes, when measured, fall within the same range as Egypt's Great Pyramid of Giza, an eerie coincidence that fuels speculation about shared architectural principles. Could this be evidence of a lost, shared knowledge, or simply a cosmic joke played by random geology? NASA's official stance remains cautious, classifying it as an interesting geological feature, while stopping short of endorsing any extraordinary explanations. What's undeniable is this: the Tycho Pyramid stands as a silent challenge to our understanding of lunar processes. Whether a quirk of nature or something more profound, it forces us to question how much we really know about the forces that shape not just our moon, but the stories we tell about it. And with every high-resolution image beamed back from orbit, the mystery only deepens. Scattered across the moon's dusty plains like cosmic fingerprints, the lunar swirls are some of the most visually mesmerizing and scientifically baffling features on the lunar surface. These bright, swirling patterns stretch for miles, their delicate wisps and loops standing in stark contrast to the dark volcanic plains they adorn. Unlike impact craters or mountains, these formations seem almost painted onto the landscape, their origins shrouded in mysteries that defy conventional explanations. What could create such elegant, otherworldly designs on a world without wind, water, or weather? The answer, surprisingly, might lie in something invisible: magnetism. Lunar swirls align eerily well with localized magnetic anomalies, patches where the moon's otherwise weak magnetic field spikes unexpectedly. NASA's Lunar Prospector mission mapped these magnetic hotspots, revealing a bizarre correlation between the swirls' bright tendrils and areas where the magnetic field is strangely strong. But here's the puzzle: the moon hasn't had a global magnetic field for billions of years. So how do these isolated pockets of magnetism persist, and why do they sculpt such intricate patterns? One leading theory suggests solar winds, the relentless stream of charged particles from the sun, are being deflected by these magnetic bubbles. Over eons, this shielding effect could prevent the surrounding soil from darkening under radiation, leaving behind brighter, protected swirls. It's a compelling idea, but it doesn't explain everything. For starters, some swirls, like the famous Lunar Gamma Formation, exhibit magnetic fields far stronger than any nearby rock should produce. Lunar geologists are stumped. The swirl's magnetism doesn't match the composition of the surrounding basalt plains. Even stranger, the swirls seem to resist the moon's natural aging process. While meteoroid impacts gradually churn and darken the lunar surface, a process called space weathering, the swirls remain strikingly bright, as if frozen in time. Some researchers speculate that the magnetic fields might be actively repelling fine dust particles, preventing them from settling. Others propose electrostatic forces are at play, levitating dust away from the swirls in a process we've yet to fully understand. Then there's the wildcard theory. Could these swirls be the scars of ancient cometary impacts? When a comet's icy nucleus vaporizes on impact, its magnetic field might briefly imprint onto the lunar crust, leaving behind these ghostly patterns. It's a fringe idea, but it gains traction when you examine swirls like Mare Ingenii, where the bright arcs mirror the sort of plasma turbulence a comet's tail might create. The deeper we dig, the more questions arise. Why do some swirls appear near the edges of massive lava flows, while others sit isolated in the middle of nowhere? Why do their magnetic fields sometimes shift over time, as if something beneath the surface is moving? Every mission that studies them, from India's Chandrayaan to NASA's Artemis, brings back data that challenges our assumptions. One thing's certain, the lunar swirls are more than just pretty anomalies. They're clues to the moon's hidden dynamism, proof that even a dead world can harbor secrets that rewrite the rules of planetary science. Whether sculpted by magnetism, etched by comets, or shaped by forces we've yet to imagine, they remind us that the moon still has stories left to tell, and we've only just begun to listen. Far beyond our moon, in the cold expanse of the Martian system, an enigmatic structure has fueled speculation for decades, the so-called monolith of Phobos. First spotted in images from NASA's Mars Reconnaissance Orbiter, this stark, rectangular slab rises abruptly from the surface of Mars' largest moon, casting a long, geometric shadow across the cratered terrain. At roughly 90 feet tall, its unnaturally straight edges and near-perfect right angles stand in defiance of the chaotic landscape around it. But here's where things get even more intriguing. Some researchers claim similar structures might exist on our own moon, hidden in plain sight. The connection between Phobos and lunar anomalies isn't as tenuous as it might seem. Both bodies share a history of bombardment, lacking the erosional forces of wind or water that shape terrestrial geology. Without these smoothing processes, any unnatural formations, whether natural or artificial, would remain preserved for eons. Astronauts like Buzz Aldrin have openly speculated about Phobos' monolith, with Aldrin calling it a potential artifact worthy of close examination. If such a structure exists there, why couldn't the moon harbor its own counterparts? High-resolution scans of the lunar surface reveal a handful of candidates' angular formations that mirror Phobos' monolith in their unnatural geometry. One, located near the crater Landsberg, appears as a towering, slab-like projection with edges too precise to dismiss as random rock formations. Another, in the rugged highlands of the moon's far side, casts a shadow that suggests a vertical structure rising from an otherwise featureless plain. Skeptics argue these are simply boulders or exposed bedrock fractures, but the consistency of their shapes raises questions. Why do these alleged monoliths appear in regions with heightened magnetic anomalies or transient lunar phenomena? Theories about their origins range from the scientific to the sensational. Some planetary scientists propose that volcanic dikes, vertical sheets of hardened magma, could explain the angular formations. Others point to erratic boulders, massive rocks ejected during impacts that came to rest in improbable positions. But the wildcard hypothesis, these structures might be remnants of an ancient, spacefaring civilization, either human or extraterrestrial. that left markers or even functional installations scattered across the solar system. The idea isn't just science fiction. Renowned astrophysicist Paul Davies once speculated about the possibility of alien artifacts hidden on the Moon, precisely because its airless, unchanging surface would preserve them indefinitely. Then there's the eerie timing. The Apollo 10 astronauts reported hearing unexplained space music, a bizarre, whistling interference, as they orbited the Moon's far side, a region where some of these monolith-like structures have been spotted. Coincidence or a clue? NASA's official stance remains grounded, attributing the phenomena to natural geology and radiostatic, but the whispers persist. Private lunar missions, like those planned by SpaceX and other ventures, could soon provide the close-up data needed to settle the debate. Until then, these silent sentinels, whether on Phobos or the Moon, stand as tantalizing reminders that our cosmic neighborhood might hold secrets we've only begun to uncover. What makes the monolith mystery so compelling isn't just the question of what these structures are, it's what they represent. If even one of them defies natural explanation, it forces us to reconsider humanity's place in the universe. Are we alone, or are we merely the latest chapter in a story written across the stars with clues hidden in plain sight, waiting on the surface of worlds we've only begun to explore? The answers, if they come, might rewrite history itself. When Neil Armstrong and Buzz Aldrin made history by stepping onto the Moon's surface during Apollo 11, the world watched in awe, but few noticed the strange details lurking in the background of their footage. Decades later, digital restoration techniques revealed anomalies in those grainy tapes that some researchers argue could rewrite the mission's legacy. Streaks of light, unexplained geometric shapes, and what appear to be distant objects moving against the starless lunar sky have ignited debates. Were the astronauts truly alone up there? One of the most scrutinized moments comes from the famous landing sequence. As the lunar module descended toward the Sea of Tranquility, a bright, elongated object appears to cross the frame just beyond Armstrong's window. NASA's official explanation attributes it to lens flare, a common optical artifact caused by sunlight reflecting inside the camera. But independent analysts counter that the object's trajectory and luminosity don't match typical flare behavior. It moves independently of the camera's panning, maintains a consistent shape, and even seems to accelerate before vanishing behind the lunar horizon. Even more puzzling, transcripts from the mission reveal an unexplained exchange between Armstrong and Mission Control, where he abruptly mentions other vehicles parked along the crater's rim before the audio cuts to static. Then there's the infamous double UFO frame, extracted from enhanced Hasselblad camera footage. Two disc-like shapes hover near the Moon's limb, perfectly aligned and identical in size. Skeptics dismiss them as dust particles or film defects, but their symmetrical positioning and the way they catch sunlight, appearing both illuminated and translucent, don't fit either explanation. Film restoration experts point out that dust motes would scatter randomly, not hold formation, while film damage rarely creates such crisp duplicate anomalies. Perhaps the most chilling detail comes from the lost telemetry tapes. Apollo 11's original high-quality recordings stored at NASA's Goddard Space Flight Center were allegedly erased and reused in the 1970s due to budget constraints. But conspiracy theorists claim key segments, including 34 minutes of unexplained gap audio, were deliberately purged. The surviving copies, they argue, show curious edits, moments where Aldrin's live commentary trails off mid-sentence, replaced by odd tonal beeps later identified as possible data transmissions. Mainstream science insists these anomalies are easily explained. A mix of camera artifacts, cosmic radiation affecting film emulsion, and the limitations of 1960s technology. Yet the persistence of these mysteries raises broader questions. Why do so many unrelated observers, from retired NASA engineers to civilian researchers, describe seeing similar unexplained phenomena in the footage? And why, decades later, does restoring these tapes continue to reveal details that defy straightforward answers? Whether these anomalies are glimpses of extraterrestrial observers, glitches in early spacefaring tech, or simply tricks of light etched into history, one thing is clear: the Apollo 11 tapes remain a Rosetta Stone of lunar mysteries. Every enhancement, every pixel scrutinized, seems to peel back another layer of questions, proof that even humanity's greatest achievement might still hide secrets waiting in the shadows. Scattered across the moon's barren landscape like half-buried eggs, the lunar domes stand as silent enigmas, smooth, rounded formations that defy the jagged chaos of impact craters and rugged highlands. These peculiar structures, some reaching over a mile in width and towering hundreds of feet high, cluster in regions like the Marius Hills and the vast plains of Mare Tranquillitatis. Their near-perfect curvature and unblemished surfaces suggest an origin far removed from the violent meteor strikes that shaped much of the moon. But what forces could have sculpted these eerie, symmetrical mounds? The prevailing scientific theory points to ancient lunar volcanism. Unlike Earth's explosive volcanoes, the moon's eruptions were likely gentler, oozing thick, pasty lava that piled up over time into domes before cooling into solid rock. Evidence supporting this lies in the dome's composition. Spectral analysis reveals materials like rhyolite or basalt, consistent with volcanic activity. Some even exhibit tiny pits at their summits, possibly collapsed lava vents. Yet this explanation hits a snag when confronted with the dome's staggering uniformity. Why do so many share nearly identical slopes, clustering in geometric arrangements that resemble deliberate patterns rather than random eruptions? Then there's the mystery of their distribution. The domes don't appear randomly. They congregate in specific regions, often near the edges of massive lava plains or along fault lines. Stranger still, some domes, like those in the Gruithuisen region, are made of silica-rich rock, which requires vastly different volcanic conditions than the moon's typical basalt flows. How could such chemically distinct formations arise so close together? Planetary geologists speculate about intrusive volcanism, where magma pooled beneath the surface without fully erupting, creating bulges that later solidified. But even this fails to explain why some domes, like the ones near the crater Hortensius, appear to sit atop raised platforms almost as if they were placed there. The anomalies multiply when you examine their surfaces. High-resolution images from orbiters like LRO reveal some domes are eerily smooth, lacking the pockmarks of micrometeorite impacts that should have battered them over billions of years. Others show faint, web-like ridges radiating from their peaks, resembling stress fractures, but from what? A handful of researchers, like the late astronomer Bruce Cornett, proposed a controversial alternative. These might not be natural formations at all. Their precision, placement, and resistance to erosion could hint at artificial origins, perhaps ancient shielding structures or even abandoned habitats constructed by a civilization lost to time. Skeptics dismiss such claims as fringe fantasy, pointing to similar domes on Earth, like Hawaii's shield volcanoes, as proof of nature's ability to create near-perfect geometries. But the moon lacks the atmospheric erosion and plate tectonics that shape terrestrial geology. Without these forces, how do these structures retain such flawless forms? Even more perplexing are thermal anomalies detected around some domes, spots that stay warmer at night than surrounding terrain, as if something beneath the surface is radiating heat. The truth may lie in a middle ground. Perhaps the domes began as natural volcanic features, only to be modified by later, unknown processes, electromagnetic forces, subsurface gas vents, or even exotic crystalline growth. Or maybe we're witnessing something entirely new, a lunar geological phenomenon without an earthly parallel. Every mission that maps these domes in higher resolution seems to deepen the mystery, revealing textures and patterns that resist easy classification. One thing is certain: these silent, curved sentinels hold clues to the moon's fiery past and possibly to untold chapters in its history. Whether born of fire, shaped by unseen hands, or forged by forces we've yet to understand, they stand as reminders that our closest celestial neighbor still guards secrets waiting to be uncovered. And with each new image beamed back from orbit, the line between natural wonder and cosmic riddle grows ever thinner. Deep within the moon's far side, where sunlight rarely reaches with full force, lies the Tsiolkovsky crater, a sprawling, 54-mile-wide impact site with a haunting secret. Across its shadowed floor, scattered like ink blots on gray parchment, are the so-called black spots, irregular patches of utter darkness that absorb light so completely, they appear as voids even in high-resolution orbital images. These aren't mere shadows or tricks of topography. Something about their composition defies reflection, swallowing up to 99% of the light that hits them. What could create such unnatural darkness on an airless world already painted in shades of charcoal and dust? The leading scientific theory points to volcanic glass. On Earth, when lava cools rapidly like when it plunges into water, it can form obsidian, a glossy, jet-black rock that reflects almost no light. Lunar geologists speculate that similar processes might have occurred during the moon's volcanic heyday, when eruptions met pockets of frozen volatiles or explosive gases, flash cooling lava into glassy deposits. The Apollo missions brought back samples of dark, glassy beads from other regions, lending credence to the idea. But here's the catch: the black spots of Tsiolkovsky are far larger and more concentrated than any known volcanic glass deposits. Their edges are jagged yet precise, like splatters of tar frozen mid-splash, and they cluster in ways that don't align with typical lava flow patterns. Then there's the thermal mystery. Observations from NASA, a diviner instrument, revealed these spots cool at an unusually rapid rate at night, faster than the surrounding basalt plains. This suggests they're not just dark, but also exceptionally efficient at radiating heat, a property that doesn't match any known lunar material. Some researchers propose they could be deposits of carbon-rich minerals, perhaps delivered by ancient cometary impacts. Others wonder if they're the remnants of a rare lunar magma type, one so rich in titanium or iron that it congealed into a light-devouring veneer. But of course, where science hesitates, speculation rushes in. Conspiracy theorists have long fixated on Tsiolkovsky's black spots, arguing their geometric distribution hints at artificial structures, perhaps solar collectors or even entryways to subsurface facilities. The crater's namesake, Russian rocket scientist Konstantin Tsiolkovsky, once mused about humanity's future in space, and some wonder if his namesake crater holds clues to someone else's past. Skeptics roll their eyes, yet even they admit the spot's light absorption properties are eerily similar to stealth coatings used in modern military technology. Coincidence or something more unsettling? The truth might lie in a combination of factors. Recent spectral analysis suggests the spots could be layered deposits, multiple thin sheets of glass or mineral piled like pages in a book, each layer trapping light in a way that amplifies the darkness. Alternatively, they might be the result of electrostatic forces, with the moon's charged environment sorting finer, darker grains into concentrated patches over millennia. Whatever their origin, the black spots remain one of the moon's most visceral anomalies. They don't just resist explanation, they seem to defy the very physics we use to understand our celestial neighbor. In a landscape where every rock and ridge tells a story of violence and time, these patches of perfect darkness whisper something else entirely. That even in the lightless reaches of space, the moon still knows how to keep a secret. One of the moon's most fleeting and enigmatic mysteries is the so-called lunar wave, a phenomenon where observers, both amateur and professional, have reported seeing ripples or rolling distortions sweep across the lunar surface like invisible fingers dragging through water. These events, documented sporadically over centuries, last mere seconds but leave behind a trail of questions. Are they tricks of Earth's turbulent atmosphere, or could they hint at something far stranger happening on the Moon itself? The earliest recorded sighting dates back to the late 1700s, when British astronomer Sir William Herschel noted a slow, undulating motion near the crater Aristarchus, as if the lunar soil itself were breathing. Modern observers describe it differently: a sudden shimmer like heat haze over desert asphalt that races across plains or crater rims before vanishing without a trace. These waves don't distort the entire visible disk, they're localized, sometimes following geographic features with eerie precision. In 2012, an amateur astronomer in Japan captured one such event on video, a pulse of distortion moving at an estimated 30 miles per hour along the edge of Mare Serenitatis, bending sunlight like a mirage before dissipating. Skeptics argue these are textbook examples of atmospheric distortion. Earth's air acts like a shifting lens, bending light passing through it, especially near the horizon where the Moon appears lowest in the sky. Turbulence, temperature gradients, and even humidity can create rippling effects. But here's the problem: many lunar wave sightings occur when the Moon is high overhead, where atmospheric interference is minimal. Even more puzzling, some waves move against the direction of upper atmospheric winds, defying conventional explanations. Then there's the thermal anomaly angle. The Moon's surface swings between extremes, from 260 degrees Fahrenheit at noon to -280 at night. Could rapid temperature changes in subsurface layers cause buckling or gas releases that briefly warp the visible terrain? Lunar geologists point to outgassing pockets of trapped volatiles like radon or helium escaping through fissures as a possible trigger. If these gases seeped up in sudden bursts, they might create a temporary refractive layer just above the soil, bending light like a prism. India's Chandrayaan orbiter detected sporadic gas releases near wave sighting locations, adding weight to this theory. But the wildcard hypothesis: transient electrostatic activity. The Moon's surface is electrically charged by solar winds, and dust grains can levitate in eerie, kilometer-high fountains during sunrise terminator events. If these charged particles organized into dense, moving sheets, could they bend light enough to mimic waves? NASA LADEE mission observed odd horizon glows caused by dust, but nothing on the scale of the reported waves. The truth might lie in a combination of factors: atmospheric quirks amplifying subtle lunar processes we've yet to fully understand. What makes the lunar wave so compelling isn't just the mystery of its origin, but the way it forces us to reconsider the Moon as a dynamic world. Even without weather or tectonics, it seems to possess a hidden vibrance, fleeting, elusive, and daring us to look closer. Whether a trick of the light or a whisper of unseen forces, these ghostly ripples remind us that some mysteries refuse to stay still long enough to be solved. In the stark, gray expanse of the Moon's far side, China's Yutu-2 rover rolled to a halt in late 2021. Its cameras locking onto something utterly unexpected: a peculiar cube-shaped object perched on the horizon. Dubbed the Mystery Hut by the Chinese Space Agency, this angular anomaly immediately ignited a firestorm of speculation. Was this a trick of light and shadow, a bizarre geological formation, or something far more extraordinary? The initial images, beamed back from the Von Karman crater, showed a stark geometric silhouette standing against the barren lunar landscape. Roughly 200 feet away from the rover, the object appeared unnaturally symmetrical, with edges so sharp they seemed almost machined. Internet sleuths and UFO enthusiasts pounced, suggesting everything from alien artifacts to abandoned lunar infrastructure. But scientists at the China National Space Administration urged caution, labeling it simply as a curious feature worthy of closer inspection. As Yutu-2 spent the next several weeks inching toward the object, NASA weighed in with a more grounded explanation. Planetary geologists pointed to the Moon's long history of violent impacts, arguing the cube was likely just a boulder, one fractured by eons of meteoroid strikes into a deceptively geometric shape. They cited examples like the infamous House Rock spotted during the Apollo 16 mission, which from a distance appeared perfectly rectangular but up close revealed itself as a mundane, if unusually angled, chunk of lunar basalt. Then came the twist. When U-22 finally closed the distance, the cube revealed itself to be something else entirely. Not a perfect geometric monolith, but a bizarrely textured, uneven formation resembling a crouching rabbit. The Chinese team playfully renamed it the Jade Rabbit, a nod to the lunar rover's nickname. Yet even this revelation left questions unanswered. Why did the object initially appear so strikingly angular from afar? Lunar terrain rarely plays such tricks on cameras without cause. Some researchers proposed an optical illusion known as pareidolia, the human brain's tendency to impose familiar shapes on random patterns. The moon's stark lighting, devoid of atmospheric softening, amplifies shadows, turning jagged rocks into seemingly perfect forms. Others noted the object's location near a fresh impact crater, suggesting it might be ejecta, a chunk of debris flung outward during a collision, fracturing in ways that created temporary geometric illusions as it settled. But the wildcard theory, the cube might have been a genuine lunar oddity, just not an artificial one. Certain volcanic formations, like columnar basalt found on Earth, can fracture into geometric pillars under specific cooling conditions. If similar processes occurred on the moon, they might produce fleeting, unnatural-looking shapes, especially when viewed from a distance. What makes this anomaly so fascinating isn't just the debate over its origins, but what it reveals about how we explore and interpret the unknown. In our eagerness to unravel the moon's mysteries, we sometimes see what we hope to find. Yet the truth, when it emerges, is often stranger than fiction, a rabbit-shaped rock where we expected a monolith, a cosmic prank played by light and geology. And perhaps that's the real lesson here. The moon's greatest trick isn't hiding secrets, but showing us how eagerly we'll chase them. Beneath the moon's scarred surface, hidden from the prying lenses of orbiters and rovers, lies one of the most tantalizing mysteries of lunar exploration, the possibility of vast, glass-lined tunnels stretching for miles through the darkness. These hypothetical passageways, first proposed by planetary scientists in the 1970s, could explain strange surface features like winding rills and collapsed skylights that dot the moon's volcanic plains. But what created them, and could they be more than just geological oddities? The most widely accepted theory traces these tunnels to the moon's volcanic past. Billions of years ago, when magma still flowed beneath the surface, rivers of molten rock may have carved out subterranean channels. As the outer layers cooled and hardened, the still liquid interior drained away, leaving behind hollow tubes. On Earth, similar formations exist like the lava tubes of Hawaii's volcanoes, but lunar gravity, 1/6 of Earth's, could have allowed these structures to grow to staggering proportions. Some estimates suggest lunar lava tubes might span hundreds of feet wide, large enough to house entire cities. Then there's the glass factor. Unlike Earth's lava tubes, which are rough and rocky, lunar tunnels might be lined with something far stranger, smooth, translucent glass. When Apollo astronauts brought back samples of lunar soil, they contained tiny glass beads, byproducts of meteoroid impacts melting the surface into quick cooling droplets. But in the vacuum-sealed environment of a lava tube, some researchers speculate that splashing magma or volcanic gases could have coated the walls in thicker, continuous sheets of glass. Japan's Selene orbiter even detected unusual reflective patches in certain rills, hinting at something mirror-like hiding below. But here's where the mystery deepens. Not all these tunnels follow predictable volcanic patterns. Some, like the enormous passage suspected to run beneath Marius Hills, align too perfectly, as if tracing a deliberate path between geological hotspots. Others terminate abruptly at what appear to be circular doors, visible in some high-res images as disc-like depressions with raised rims. Conspiracy theorists argue these could be engineered airlocks, remnants of an underground lunar base built by an ancient civilization. Mainstream science scoffs, yet even NASA's own studies concede that stable subsurface tunnels could theoretically be repurposed as habitats, their glass walls acting as natural radiation shields. The most compelling evidence might come from gravity maps. NASA's Grail mission, which measured subtle fluctuations in the Moon's gravitational field, detected long, tube-like voids beneath regions like Oceanus Procellarum, some stretching over 30 miles. These invisible rivers of emptiness bend gravity in ways that match models of hollow lava tubes. But why do some exhibit bizarre thermal properties, staying oddly warm even during the frigid lunar night? Whether carved by fire, shaped by unseen hands, or simply the product of a stranger geology than we've yet imagined, these glass tunnels represent more than just a scientific curiosity. They could be the key to humanity's future on the Moon's natural shelters from cosmic rays and micrometeorites, preserving clues to the solar system's past while offering a blueprint for off-world colonization. The deeper we look, the more these phantom passageways beckon, their glassy walls perhaps holding reflections not just of light, but of possibilities we're only beginning to glimpse. Among the Moon's countless craters, Euclid stands out not for its size or depth, but for what appears to lie just beyond its rim. Stretching across the surrounding plains like ghostly blueprints, a series of grid-like patterns has sparked debate for decades. From a distance, these intersecting lines resemble the symmetrical streets of a buried metropolis, earning the site the nickname, the Lunar City. But are these grids the remnants of an ancient alien settlement or something far more mundane? The first hint of this anomaly came from early lunar orbiter images, where faint, straight lines formed near perfect rectangles across the terrain. Some stretches measured miles long, intersecting at precise angles that seemed too orderly for natural formations. When magnified, certain sections even appeared to branch into smaller divisions, evoking the layout of urban blocks. Conspiracy theorists wasted no time declaring it proof of lunar architecture, pointing to similar grid patterns found in ancient terrestrial cities like Mohenjo-Daro or Teotihuacan. But before we entertain cosmic construction crews, let's examine the science. Geologists propose a far less sensational explanation: fractured lava plains. The region around Euclid is part of the Moon's vast volcanic mare, where molten rock once flooded the surface before cooling into brittle sheets. As these sheets contracted over time, they could have cracked under stress, much like drying mud forms polygonal patterns. The Moon's lack of erosion would preserve these fractures with unnatural crispness, creating the illusion of deliberate design. Supporting this, recent spectral analysis reveals the grid lines align with mineralogical discontinuities, subtle shifts in basalt composition that could indeed trace ancient stress points. But here's where the mystery resurfaces. Not all the lines fit this model. Some intersect at angles unseen in natural fracture networks, while others curve or terminate abruptly, as if following an unseen blueprint. Even stranger, a few segments appear raised rather than recessed, suggesting material was added rather than split apart. Could these be the worn-down ribs of collapsed lava tubes, their arched ceilings leaving skeletal outlines? Or might they mark the boundaries of long-vanished magnetic fields, which some studies suggest can influence how lunar soil settles? The pixelation argument adds another layer. Early lunar images were low resolution, and compression artifacts often created artificial straight lines where none existed, a phenomenon seen in everything from satellite maps to retro video games. Yet even in modern high-definition scans from NASA, a lunar reconnaissance orbiter, portions of the Euclid grid retain their eerie geometry. If it's just pixelation, why do the lines persist across multiple imaging technologies spanning half a century? Perhaps the most intriguing clue lies in the grid's location. Euclid sits at the intersection of several gravitational anomalies where subsurface density variations suggest hidden structures. Could buried lava tubes or mineral deposits have guided the fractures into such unnaturally uniform shapes? Or, as a handful of researchers speculate, might we be seeing the faint imprint of something else entirely, a relic from a time when the moon was anything but lifeless? For now, the lunar city remains a Rorschach test etched into rock. To some, it's a testament to nature's ability to mimic order. To others, it's a tantalizing hint of stories untold. One thing's certain, until we tread those grid-lined plains ourselves, Yucat's secrets will stay suspended between imagination and evidence, waiting for the day we're ready to read them. Among the most persistent and controversial lunar anomalies is the legend of the floating castle, a towering, spire-like structure that allegedly appears in a single, grainy frame from the Apollo missions. First brought to public attention by independent researchers scrutinizing NASA archives, this anomalous formation appears to hover above the lunar surface, casting a shadow that suggests it's suspended in midair. Believers argue it's evidence of advanced alien technology or remnants of a lost lunar civilization, while skeptics dismiss it as a combination of camera artifacts and pareidolia. But what makes this particular anomaly so enduring, and why does it continue to split opinion decades after its discovery? The image in question, reportedly taken during Apollo 15's orbit, shows a jagged, irregular shape rising near the crater Tsiolkovsky. Its base seems disconnected from the terrain below, creating the illusion of levitation. Proponents of the floating castle theory point to its angular, geometric features, layers that resemble stacked platforms or battlements, giving it an almost medieval appearance. Some even claim to discern reflective surfaces along its edges, as if catching sunlight like polished metal. These details, they argue, defy natural explanations. If it were just a trick of light, why would the structure maintain such consistent, hard-edged proportions across multiple enlargements? And why does its shadow appear to anchor it to nothingness, as if defying gravity itself? NASA's official stance attributes the anomaly to a simple photographic glitch, a combination of lens flare, film grain, and the high-contrast lighting of the lunar environment. The moon's lack of atmosphere means shadows are razor-sharp, and even minor irregularities in terrain can cast deceptive silhouettes. Critics also highlight the Apollo camera's limitations: grainy resolution, light leaks, and the occasional dust speck on the lens. To them, the floating castle is no different from seeing shapes in clouds, an illusion amplified by our tendency to seek patterns in randomness. But here's where the debate intensifies. Independent analysts using modern image enhancement techniques claim the structure's internal geometry holds up under scrutiny, with repeating right angles and parallel lines that mirror architectural principles. Some researchers, like the late astronomer Bruce Cornett, suggested that electrostatic forces or residual magnetic fields could theoretically levitate certain lunar materials, creating temporary structures that appear to float. Others propose a more radical idea. What if this is a piece of machinery, abandoned or still operational, left behind by a non-human intelligence? The timing of the photograph adds another layer of intrigue. Apollo 15 was one of the most scientifically robust missions, carrying advanced mapping cameras and instrumentation. If the floating castle were merely a glitch, why wasn't it replicated in other frames taken seconds apart? And why do similar anomalies, though less dramatic, appear in Soviet lunar program images from the same era? Conspiracy theorists whisper about suppressed data, pointing to gaps in mission transcripts and the occasional lost film reel as evidence of a deliberate cover-up. Yet for all the speculation, the truth may lie in the moon's uncharted geology. Transient lunar phenomena, like the light flashes and shadow movements we've discussed earlier, prove that the moon is far from static. Could the floating castle be an extreme example of this, a rare plasma discharge, an electrostatic dust formation, or even a mirage like refraction caused by temperature gradients in the lunar soil? Without boots on the ground to investigate, we're left with theories chasing shadows. What makes the floating castle so compelling isn't just the question of what it is, but what it represents. It's a Rorschach test for how we view the unknown. To some, it's a smoking gun of extraterrestrial visitation. To others, a testament to human imagination. And for a handful, it's a reminder that the moon, even after centuries of observation, still holds mysteries that refuse easy answers. Whether a trick of the lens or a glimpse of something monumental, its legend persists floating just beyond our grasp, daring us to look closer. Sprawling across the moon's mare ingenii like cracks in a frozen lake, the so-called lunar spiders present one of the most visually arresting and scientifically divisive anomalies on the lunar surface. These intricate, web-like formations consist of dozens of thin, radiating tendrils that stretch for miles across the dark volcanic plains, their branching arms converging at central hubs like some colossal arachnid frozen in stone. First spotted in high-resolution images from Japan's Selene orbiter, these features defy easy classification, with some strands measuring barely a few yards wide yet extending over 30 miles in near-perfect straight lines. What kind of geological process could create such delicate, sprawling patterns on an airless world devoid of water, wind, or weather? The leading explanation points to cryovolcanism, a phenomenon where volatile compounds like water or methane erupt as icy slurries rather than molten rock. On worlds like Saturn's moon, Enceladus, or Neptune's Triton, cryovolcanoes sculpt bizarre landscapes with their frigid eruptions. While the moon lacks the subsurface oceans of these distant bodies, traces of water ice lurk in permanently shadowed craters, and some researchers speculate that pockets of volatile gases may have once erupted near the poles. If these gases burst through the surface in explosive geysers, the resulting plumes might have deposited spider-like patterns as they fell back to the ground. The Mare Ingenii region, with its history of magnetic anomalies and odd reflective properties, could have been a hotspot for such activity billions of years ago. But here's where the theory meets resistance. Cryovolcanic eruptions typically leave behind central vents or domes, yet many lunar spider formations lack any obvious source crater. Instead, their tendrils appear to emerge from flat, uninterrupted plains. Even stranger, some strands crosscut each other in intersecting networks, suggesting multiple eruptive events, yet the surface shows no signs of layered deposits or overlapping debris fields. Thermal imaging adds another wrinkle. Certain spiders exhibit unusual heat retention, staying marginally warmer than the surrounding terrain during lunar night. If these were ancient cryovolcanic remnants, shouldn't they have thermally equilibrated over millennia? Alternative explanations range from the mundane to the extraordinary. Some planetary geologists propose electrostatic phenomena, charged dust particles organizing themselves into fractal patterns under the influence of the moon's local magnetic fields. Others point to dike swarms, where underground magma intrusions fracture the surface in radial patterns, though the moon's volcanic dikes typically appear more jagged and discontinuous. Then there's the wildcard hypothesis. Could these be the fossilized remains of vast mycelium-like structures from a time when the moon harbored subterranean liquid reservoirs? It sounds like science fiction, but recent studies of extremophiles on Earth show microbial life can form eerily similar branching networks in underground caves. The debate takes on new urgency as space agencies target the moon's south pole for future landings, a region where similar spider-like features have been tentatively identified. If these formations prove to be cryovolcanic in origin, they could mark underground reservoirs of precious water ice or other volatiles, critical resources for sustained lunar habitation. But if there's something else entirely, whether electrostatic oddities or the lingering ghosts of some unfathomable process, they stand as a reminder that the moon still holds geological puzzles unlike anything we've encountered on Earth. What makes the lunar spiders so mesmerizing isn't just their otherworldly beauty, but the way they stretch our understanding of planetary science. In their delicate, lace-like patterns, we see the fingerprints of forces both familiar and alien, a testament to the fact that even our closest celestial neighbor still plays by rules we're only beginning to decipher. Whether ancient ice volcanoes, dancing dust, or something beyond our current theories, these silvery webs cling stubbornly to their secrets, waiting for the day we're ready to unravel them. Aristarchus crater has been flickering like a cosmic beacon for centuries, an erratic light show that refuses to be ignored. As far back as 1838, the astronomer Sir John Herschel documented luminous flashes within its jagged walls, convinced he was witnessing volcanic eruptions. But the Moon, we now know, has been geologically dead for billions of years. So what's causing these eerie pulses of light, sometimes white, other times tinged red or blue, that continue to baffle observers to this day? The modern era brought no shortage of sightings. During NASA Apollo 11 mission, Michael Collins radioed mission control about an unusual glow near Aristarchus, describing it as a very bright little spot that pulsed steadily before vanishing. Decades later, Japan's Selene orbiter captured thermal anomalies in the same region, brief, intense heat spikes with no visible source. Even amateur astronomers regularly report flashes so vivid they're visible through backyard telescopes. The European Space Agency maintains a dedicated database logging over 300 such events in Aristarchus alone. Scientists scramble for explanations. One faction points to triboluminescence, a phenomenon where stressed rocks emit light when fractured, perhaps by moonquakes or shifting subsurface plates. Others propose electrostatic discharges, where charged dust particles lofted by micrometeorite impacts create tiny lightning-like flashes, but neither theory fully accounts for the scale or color variations of these lights. Triboluminescence typically produces brief blue-white sparks, not the prolonged crimson glows witnessed in Aristarchus, and electrostatic discharges would likely scatter randomly, yet these flashes cluster along the crater's western rim with uncanny consistency. Then there's the radon hypothesis. Orbital spectrometers have detected sporadic puffs of radioactive radon gas seeping from Aristarchus, leading some researchers to suggest decay chains might excite lunar dust into glowing. It's a compelling idea, except radon's half-life is just 3.8 days. For it to explain centuries of recurring flashes, there'd need to be an ongoing source replenishing it beneath the surface. The most tantalizing clue lies in the timing. Many flashes coincide with Earth's magnetosphere passing through solar wind disturbances, hinting at some electromagnetic trigger. In 2011, when a coronal mass ejection struck the Moon, Aristarchus lit up like a signal flare just hours later. Could the crater be acting as a natural particle accelerator, funneling solar energy into localized bursts? Or, as a handful of theorists suggest, is something beneath its floor reacting to these space weather events in ways we don't yet understand? Perhaps the only thing more mysterious than the lights themselves is their effect on those who witness them. Apollo astronauts reported an unsettling, tingling sensation when observing Aristarchus through their spacecraft windows, as if the crater was somehow alive with energy. Modern telescopic observers describe an almost hypnotic quality to the flashes, a rhythmic pulsing that seems to pause, as if waiting for a response. Coincidence? Pareidolia, or the quiet hum of a mystery we've yet to decode. One thing's certain, Aristarchus refuses to be just another crater. Whether a geological oddity, a cosmic energy sink, or something more profound, its flickering depths remind us that the Moon's stillness is an illusion. Beneath the dust and silence, something stirs, and it's been trying to catch our attention for generations. Among the Moon's many fleeting illusions, none are as visually striking or as hotly debated as the so-called lunar X and V. These temporary formations, visible only under precise lighting conditions, appear as crisp, geometric shapes etched onto the lunar surface for just a few hours each month. To the naked eye, they look almost intentional, like celestial signposts or symbols carved into the dust. But are these shapes mere tricks of light, or could they hint at something more deliberate hidden in the moon's architecture? The lunar X emerges near the crater Werner, where the interplay of sunlight and shadow transforms a cluster of intersecting ridge lines into a perfect angular letter. It's not an object, but an optical phenomenon, a product of the sun's rays striking the rims of three smaller craters at an exact 4-degree angle. When aligned just right, their combined shadows and illuminated slopes create the illusion of a stark, glowing X suspended against the darker plains. The V, appearing near the crater Euclid, forms through a similar alchemy of light and topography. Here, two converging ridges and a central peak conspire to project a razor-sharp V shape onto the surface, visible only during a narrow window before the sun's angle shifts and the illusion dissolves. Skeptics argue these formations are textbook examples of pareidolia, the human tendency to impose familiar patterns on random shapes. After all, the moon's surface is a graveyard of jagged edges and intersecting lines, any of which could form temporary letters or symbols under the right conditions. Even on Earth, we see faces in clouds or animals in rock formations. The lunar X and V are just cosmic extensions of this instinct, but here's where the debate takes an intriguing turn. Unlike fleeting pareidolia, these shapes reappear with clockwork regularity, always in the same locations and under identical lighting. Could there be more to their precision than chance? Some researchers point to the shape's unnatural symmetry. The X's intersecting lines maintain near-perfect 90-degree angles, while the V's arms are equally balanced as if calibrated. Even more curious, both formations appear in regions rich in other anomalies, magnetic disturbances, transient lunar phenomena, and even the infamous grid patterns we discussed earlier. Coincidence, or could these be markers, intentionally positioned by some long-lost lunar architects to signal points of interest? Ancient astronaut theorists love this idea, suggesting the X and V might highlight entrances to subsurface tunnels or energy hotspots. Mainstream science rolls its eyes, of course. Lunar geologists demonstrate how simple slope angles and albedo variations, the reflectivity of different soils, can create these illusions without any intelligent design. High-resolution scans reveal the perfect X and V are actually rough, uneven terrain up close, their polish an artifact of distance and lighting. And yet, even the staunchest skeptics admit there's something uncanny about how reliably these shapes snap into focus, as if the moon itself is winking at us through geometry. Perhaps the most compelling aspect of this mystery isn't whether the X and V are artificial, but why they captivate us so deeply. For centuries, humans have projected meaning onto the moon, seeing gods, rabbits, and faces in its plains. These transient shapes tap into that same longing, a desire to find order in the cosmos. Whether tricks of light or something more profound, they remind us that the moon isn't just a rock, it's a canvas. And sometimes, just for a few hours, it seems to sketch symbols in the sunlight, daring us to decipher them. One of the moon's most baffling behaviors isn't what appears on its surface, but what disappears. Across decades of observations, astronomers have documented a handful of craters that seem to vanish into thin vacuum, their outlines fading or transforming between images taken years apart. The most famous case lies in the rugged highlands near the crater Dionysius, where a small but distinct depression recorded by the Lunar Orbiter missions in the 1960s simply wasn't there when Japan's Kaguya probe revisited the area 40 years later. No fresh impact debris, no landslides, just an empty stretch of regolith where a crater once stood. How does a hole in the moon simply fill itself in without a trace? The leading scientific explanation points to a process called lunar outgassing. Beneath the moon's dusty crust, pockets of trapped volatiles, gases like radon, helium, or even carbon dioxide, might periodically burst through fissures, jetting upward like invisible geysers. These eruptions could loft fine dust particles high enough to settle back down, gently blanketing smaller craters over centuries. Supporting this, NASA, a lunar reconnaissance orbiter, has detected sporadic puffs of gas near sites where craters have vanished, though the mechanism isn't perfectly understood. If the Moon occasionally exhales, could these brief gusts be enough to erase surface features over time? But here's the catch: some disappearing craters are too large for dust redistribution alone to explain. In the Mare Tranquillitatis, a mile-wide depression documented by early telescopic observers now shows only a faint discoloration. No rim, no bowl, just a stain on the plains. Lunar geologists propose an alternative: electrostatic levitation. The Moon's surface is electrically charged by solar winds, causing dust grains to hover and migrate in strange, slow-motion waves. Over millennia, this creeping tide might smooth away smaller formations, though the scale of some vanishing still strains credibility. Then there's the wild card: imaging anomalies. Early lunar photographs were plagued by low resolution, high contrast, and occasional processing errors. Shadows could exaggerate tiny dips into apparent craters, while sun angle changes might erase them in later shots. Even modern orbiters aren't immune. Overlapping passes sometimes create optical illusions where parallax shifts make features appear to move or vanish. But this doesn't explain independent visual confirmations, like 19th century astronomers who meticulously sketched craters that no longer match today's maps. The most unsettling theory: some craters might not be craters at all. Transient lunar phenomena, those flickering lights and shadows we've discussed, often cluster near these volatile sites. Could certain craters actually be temporary phenomena themselves? Perhaps depressions caused by subsurface collapses, gaseous voids that later inflate unseen, or even bizarre electrostatic formations that dissipate when conditions change. The Moon, it seems, enjoys playing tricks on us, offering up features that dissolve like mirages the moment we think we've pinned them down. What makes these vanishing acts so compelling isn't just the mystery of where they go, but what they reveal about the Moon's hidden dynamism. We assume it's a dead world frozen in time, yet its surface still flickers with changes we can't fully explain. Whether driven by gas, dust, or forces we've yet to imagine, these disappearing craters remind us that the Moon is far from finished with its performance, and we're still learning how to watch the show. Tucked away in the shadowed recesses of certain lunar craters, a series of stepped formations rise like the ruins of an ancient amphitheater. These tiered structures, often referred to as the lunar stairs, descend in near-perfect, equidistant levels, some spanning hundreds of feet across with edges so sharp they appear carved rather than eroded. The most prominent examples cluster around the inner walls of craters like Pythagoras and King, where sunlight catches their edges at oblique angles, revealing a precision that gnaws at the boundaries of natural geology. Are these merely the work of billions of years of meteoroid impacts and thermal stress, or could they hint at something more deliberate? At first glance, the stairs seem like textbook examples of slumped terraces, common in large impact craters where the walls collapse inward in stages, creating concentric benches. Earth's own meteor crater displays similar features on a smaller scale, but lunar geologists hit a snag when they measured the treads. Many are eerily uniform, with step heights and depths that vary by less than 10% across vast distances. On a world without wind or water to smooth irregularities, such consistency is unusual. Even stranger, some treads intersect at near-perfect right angles, forming what look like deliberate pathways or platforms. High-resolution scans from NASA, a lunar reconnaissance orbiter, reveal microfractures along the edges, yet the overall geometry remains stubbornly geometric. Then there's the material mystery. Spectral analysis shows these terraces often comprise different minerals than the surrounding crater walls. Higher concentrations of anorthosite, a reflective, crystalline rock that forms under specific thermal conditions. One theory suggests that as the moon's magma ocean cooled billions of years ago, denser minerals sank while lighter anorthosite rose, forming layered sheets. Later impacts could have exposed these layers, creating the illusion of craftsmanship, but critics note that anorthosite typically fractures unevenly. It shouldn't produce such clean, repeating steps without external forces shaping it. The debate takes a speculative turn when examining the stairs' alignment. In King Crater, 3 distinct terrace sets converge at a central point, their angles mirroring the architectural principles of ziggurats or pyramidal step wells found in ancient Earth cultures. Coincidence, or could tidal forces from Earth's gravitational pull, which still shapes the moon's interior, have somehow sculpted these features with rhythmic precision? A handful of researchers even float the idea of electrostatic molding, where charged dust particles aligned by magnetic anomalies might have built these structures grain by grain over eons. Yet for all the theories, the lunar stairs resist easy categorization. They exist in a gray area between known geology and something just beyond our understanding, a reminder that the moon's surface is a palimpsest, its story written in layers we're only beginning to peel back. Whether nature's patient artistry or silent testaments to forces unseen, these terraces stand as invitations to look deeper, to question not just what we see, but how we see it. And with every new orbital pass, the stairs seem to whisper, climb further. The view from the next step might change everything. The moon shouldn't have a magnetic field. At least not like Earth's. Our planet's protective magnetic shield comes from a churning molten core, but lunar geology suggests its core cooled and solidified billions of years ago. Yet spacecraft keep detecting strange, localized pockets of magnetism, some strong enough to deflect solar winds in miniature versions of Earth's magnetosphere. These anomalies don't behave like random blips. They cluster in specific regions, often overlapping with other lunar oddities like swirls or ancient lava tubes. What's creating these ghostly magnetic fields, and why do they seem to guard the moon's strangest secrets? Mainstream planetary science offers 2 explanations, both rooted in cataclysmic violence. The first points to asteroid impacts. When massive space rocks slam into the moon, their metallic cores can vaporize on impact, scattering iron-rich particles across the surface. These fragments, if magnetized before impact, might preserve faint fields in the lunar crust. The second theory involves the moon's chaotic early history, when massive impacts like the one that carved the South Pole Aitken Basin could have triggered temporary magma oceans. As these molten seas cooled, minerals within them might have aligned with any existing magnetic field, freezing those orientations into the rock-like cosmic snapshots. But here's where the plot thickens. Some magnetic hotspots don't match impact sites or volcanic deposits. The Lunar Gamma Swirl, that eerie, bright formation we discussed earlier, sits atop one of the moon's strongest magnetic anomalies, yet there's no crater large enough nearby to explain it. Even stranger, certain magnetic zones seem to shift over time, as if something beneath the surface is moving. NASA's Lunar Prospector mission mapped these fluctuations, revealing fields that strengthened or weakened unpredictably over months. That's not how solid rocks behave. This inconsistency fuels alternative theories, the most tantalizing being buried metallic structures. Imagine vast sheets of iron-rich material, perhaps remnants of an ancient asteroid core or even manufactured alloys, lying just beneath the dust. Proponents note that some anomalies form near-perfect geometric shapes when mapped, like the rectangular patch near the crater Gerasimovich. Others cluster along what appear to be subterranean fault lines, suggesting intentional placement. Could these be the ruins of some lunar infrastructure, its metallic bones still humming with residual magnetism? The wild card in this debate comes from Apollo-era lunar samples. Rocks brought back by astronauts occasionally contained nanophase iron, tiny, highly magnetic particles that shouldn't exist in the moon's oxygen-starved environment. Some researchers speculate these could be remnants of advanced metallurgy, while others argue they're byproducts of micrometeorite impacts superheating the soil. Either way, their presence complicates the narrative. What makes these magnetic mysteries so compelling isn't just their defiance of expectations, but their potential utility. Future lunar bases could harness these anomalies as natural radiation shields, creating safe zones amid the moon's deadly solar wind exposure. Some even speculate they might mark deposits of rare metals, turning these scientific curiosities into economic assets. Until we drill beneath the surface, though, their true nature remains suspended between fact and speculation, a reminder that even a dead world can still hold surprises in its bones. One of the moon's most tantalizing and terrifying features isn't something protruding from its surface, but something plunging into it. Scattered across the lunar maria, those dark, frozen seas of ancient lava are gaping holes so deep their bottoms vanish into absolute blackness. These vertical shafts, some spanning hundreds of feet wide, were first spotted by Japan's Kaguya orbiter in 2009, their yawning mouths appearing like puncture wounds in the moon's dusty skin. But unlike impact craters which spread debris in all directions, these pits plunge straight down, their walls sheer and smooth as if carved by some cosmic drill. What force could create such perfect voids, and where do they lead? The prevailing theory points to collapsed lava tubes tunnels left behind by rivers of molten rock that once flowed beneath the moon's surface. As the lava drained away, it left behind hollow cavities, their ceilings occasionally caving in to create these dramatic skylights. On Earth, similar formations exist in places like Hawaii's Kazumura Cave, where sections of volcanic tubes have collapsed, revealing hidden passageways below. But lunar gravity, 1/6 of Earth's, could have allowed these tubes to grow to staggering proportions. Some estimates suggest they might stretch for miles, with ceilings high enough to dwarf the largest terrestrial cathedrals. Yet the moon's pits defy easy comparison. The most famous example, the Mare Tranquillitatis pit, measures over 300 feet across and drops at least 100 feet before vanishing into shadow. But radar scans suggest its true depth could exceed 500 feet. Even stranger, thermal imaging reveals these pits maintain a near-constant temperature, shielded from the moon's extreme surface swings. That makes them potential oases in a lethal environment, natural shelters from radiation, micrometeorites, and temperature extremes that could one day house lunar bases. But here's where the mystery deepens. Not all pits align with known lava tube paths. The Marius Hills Hole, for instance, sits isolated in a region with no obvious volcanic history. High-resolution scans of its interior reveal strange, shelf-like protrusions along its walls, layers that don't match typical lava flow stratigraphy. Some researchers speculate these could be sedimentary deposits from ancient volatile eruptions, while others whisper about structural reinforcements, as if the pit were shaped or even utilized by intelligent hands. The wild card, some pits exhibit bizarre magnetic readings. The Mare Ingenii hole, located near the moon's south pole, sits atop one of the strongest localized magnetic anomalies on the lunar surface. Solar winds, which normally bombard the moon unimpeded, curve around this region as if deflected by an invisible shield. Could metallic deposits lie beneath these pits, remnants of asteroid impacts or even artificial constructs? Or are we seeing evidence of some exotic lunar geology, where underground currents generate their own magnetic fields? Perhaps the most unsettling question isn't what created these holes, but what might lurk inside them. In 2022, NASA, a lunar reconnaissance orbiter, angled its camera to peer directly into the Mare Tranquillitatis pit, capturing the first glimpse of sunlight touching its floor. What it revealed defied expectations, a rubble-strewn chamber with passages branching into darkness, suggesting a network far more extensive than imagined. Future missions, like Japan's planned robotic exploration of the Marius Hills Hole, aim to drop probes into these abysses, mapping their depths in ways orbiters cannot. Until then, these lunar holes remain both promise and enigma, gateways to shelter or portals to the unknown, natural formations or cosmic rabbit holes leading to realms we've yet to imagine. One thing's certain, the moon's surface is only the beginning of its story. Below the dust and sunlight, in the perpetual night of those silent shafts, lies a world waiting to be explored, and it may hold secrets that rewrite our future among the stars. Beneath the moon's sunlit plains, hidden in plain sight, lie the eerie trails of the ghost crater chain's phantom impressions that flicker into view only when sunlight strikes at razor-thin angles, revealing ghostly rings and crescents etched into the landscape like cosmic footsteps. These formations aren't fresh impacts or recent scars. They're the faded remnants of ancient collisions, their outlines so subtle they vanish entirely when viewed overhead. Yet under the right lighting, they emerge as delicate chains, sometimes dozens of miles long, threading across the lunar surface like stitches in a celestial quilt. How could craters so vast become nearly invisible, and why do they align with such uncanny precision? The answer lies in a process called burial by lava. Billions of years ago, during the moon's volcanic heyday, floods of molten rock surged across its surface, pooling in low-lying basins. When these lava flows encountered older craters, they didn't erase them entirely. Instead, they filled them like molds, preserving their shapes beneath a thin, solidifying skin. Over time, micrometeorite bombardment and electrostatic dust migration smoothed the surface further, leaving only the faintest undulations to hint at what lay buried. But when the sun grazes these plains at angles of less than 10 degrees, the trapped craters cast elongated shadows, their rims peeking through the veneer like whispers from the moon's violent past. What's truly baffling isn't just their faintness, but their arrangement. Unlike random impact clusters, ghost chains often follow near-perfect arcs or straight lines, as if something guided their formation. One of the most striking examples winds through the vast oceanus Procellarum, where a dozen ghost craters form a graceful curve spanning over 60 miles. Lunar geologists offer two explanations: secondary crater chains, formed when debris from a massive primary impact struck the surface in a shotgun-like pattern, or volcanic pit chains, where collapsing lava tubes created sinkholes in a row. Yet neither theory fully accounts for the ghost chain's eerie regularity or their haunting thermal signatures. Infrared scans reveal something peculiar. These ghost craters cool at different rates than the surrounding plains. At night, their buried rims retain traces of warmth, suggesting the lava that filled them has subtly different thermal properties, perhaps due to variations in density or mineral content. Some researchers speculate that gases trapped beneath the lava might have left porous layers, creating insulating blankets that slow heat loss. Others point to odd magnetic readings near certain chains, hinting at metallic debris from the original impact still lurking below. But the wildest theory, these ghost chains might be more than just geological relics. A handful of astronomers note that some alignments mirror the predicted paths of massive, fragmented comets that could have grazed the moon in antiquity, their icy cores exploding in mid-air like cosmic shotgun blasts. If true, these phantom trails could be the fingerprints of a cataclysm so violent, it reshaped entire regions not just on the moon but perhaps on Earth too. The ghost craters' greatest gift isn't just their mystery but their impermanence. They remind us that even the moon's most enduring features are fleeting in cosmic terms, fading, shifting, and waiting for the perfect light to tell their stories. And with every new orbiter's pass, these spectral chains whisper a tantalizing question: what else lies buried just beneath our sight on the world we thought we knew? One of the most iconic and hotly debated lunar anomalies isn't a tower, a crater, or a swirling pattern, but something far more primal, a face. In 1976, NASA, a Viking 1 orbiter captured an image of the Cydonia region on Mars that sent shockwaves through the public. a mile-long mesa eerily resembling a human face staring blankly into space. But what few remember is that our own moon has its own version of this phenomenon, lurking in the rugged terrain of the Mare Crisium. The original images, taken by Lunar Orbiter 3 in the 1960s, showed a cluster of hills and shadows that, when viewed from a specific angle and under low resolution, appeared to form a stylized human profile, complete with a pronounced brow ridge, nose, and even parted lips. Unlike the Martian face, which was later debunked by higher resolution imagery, the lunar version never gained the same pop culture traction. Yet for a handful of researchers, it remained a stubborn enigma. Was this just another case of pareidolia, the brain's tendency to see familiar shapes in random patterns, or something more deliberate? Modern high-resolution scans from NASA, a lunar reconnaissance orbiter, tell a different story. The face, when examined under crisp, direct sunlight, dissolves into a series of unremarkable ridges and impact scars. Their eyes become sunken pits, the mouth a shallow depression, and the once distinct profile blends into the chaotic background. At first glance, it seems like just another trick of light and shadow, except for one curious detail. The formation sits at the convergence of two faint, nearly straight lines that extend for miles across the Mare, resembling the kind of geometric alignments we've seen near other lunar anomalies. Skeptics argue the entire phenomenon is a textbook example of how low resolution and oblique lighting can conjure illusions. They point to similar faces spotted in everything from clouds to toast, a byproduct of our brain's hardwired need to recognize patterns, especially human ones. Yet, even debunked, the lunar face retains a strange allure. Why? Because it taps into something deeper than logic, the uncanny sense that we're being watched, even by a lifeless rock 250,000 miles away. Perhaps the most fascinating twist lies in the cultural echoes. Ancient civilizations from the Maya to the Inuit wove stories of lunar deities with human-like visages. Were these myths purely imaginative, or could they have been inspired by observations, intentional or accidental, of this very formation? Modern astronomers dismiss the idea, but the coincidence lingers. In the end, the lunar face is less about what's actually there and more about what we want to see. It's a mirror held up to our own curiosity, our hunger for meaning in the void. And whether a trick of the light or a whisper from the past, it reminds us that the moon's greatest mysteries might not lie in its craters or domes, but in the stories we tell ourselves when we gaze at its silent surface. The moon has a strange way of swallowing signals whole. During multiple missions, both manned and robotic, astronauts and ground control have reported sudden, inexplicable dropouts in radio transmissions when orbiting or passing over specific regions of the lunar surface. These so-called radio silence zones don't just weaken signals, they sever them completely, as if someone flipped a cosmic off switch. The most notorious example occurred during Apollo 10, when the spacecraft passed over the far side's Mare Smythii region. For nearly 6 minutes, all communication with Houston vanished, not just static, but total dead air. When contact resumed, the crew reported hearing what they described as electronic howling, a sound unlike any interference they'd trained for. Scientists scrambled for explanations. The leading theory pointed to the moon's mass concentrations of dense material lurking beneath its maria, remnants of ancient asteroid impacts. These gravitational anomalies could theoretically distort radio waves passing overhead, bending them away like light through a funhouse mirror. But here's the catch. Subsequent mapping by NASA, a Grail mission, revealed that not all radio silence zones align with known mascons. Some hover over geologically bland plains, while others cluster near regions with no discernible gravitational quirks. Then there's the timing mystery. During the Soviet Luna 22 mission in 1974, the probe's radio failed repeatedly over the crater Jules Verne, but only during lunar dawn. As sunlight crept across the landscape, the blackout ceased, only to resume precisely 12 hours later at dusk. This cyclical pattern suggests something other than random interference. Thermal stress, perhaps, but why would temperature shifts affect radio waves in such localized, predictable ways? The wild card theory involves electromagnetic pollution, not from us but from something already there. In 2012, India's Chandrayaan orbiter detected bizarre, ultra-low frequency pulsing near 3 of the most notorious silence zones. These pulses didn't match known solar or cosmic background noise. Some researchers speculate they could be echoes of ancient technology buried beneath the regolith, perhaps still drawing power from underground thermal vents or residual radioactivity. Others propose natural moonquakes might be squeezing piezoelectric minerals like quartz, generating rogue electromagnetic fields, but the most chilling data comes from the shadows. Several silence zones overlap exactly with areas where Apollo astronauts reported visual anomalies, flashing lights, glinting objects, even what one described as a metallic grid, briefly visible in the dust before vanishing. Coincidence, or could something beneath the surface be actively disrupting both sight and sound? Radio silence might seem like a minor glitch in the grand scheme of lunar mysteries until you consider what it implies. These aren't just dead zones, they're blind spots in our understanding, places where the moon refuses to speak. And in that silence, we're left to wonder, is it hiding something, or is it waiting for us to ask the right questions? From towering spires to flickering lights, vanishing craters to geometric patterns etched into the dust, our journey through the moon's 25 most baffling anomalies has revealed a world far stranger than textbooks suggest. Each of these mysteries, the shard's impossible angles, Aristarchus's pulsing glow, the lunar swirl's magnetic ballet, chips away at the idea of the moon as a barren, unchanging rock. Instead, we're left with a celestial neighbor that hums with unanswered questions, where shadows move without wind and structures defy geology's rules. Consider the implications. The Blair Cuspids perfect alignment suggests forces beyond random chance. The Tycho Pyramid's eerie symmetry mirrors Earth's ancient monuments. And the radio silence zones, they hint at a moon that doesn't just keep secrets, it actively muffles them. These aren't isolated oddities, they form a tapestry of enigmas that push us to rethink everything from lunar volcanism to humanity's place in the cosmos. But the real magic lies in what we haven't solved. Why do transient phenomena cluster in specific regions like cosmic hotspots? How could glass-lined tunnels or magnetic anomalies persist for billions of years? And what, or who might have left markers like the Euclid grid or the floating castle? Science offers theories, but the moon consistently dances just beyond our grasp, reminding us that some truths aren't just hidden, they're waiting for the right moment to reveal themselves. This is where you come in. The golden age of lunar exploration is just beginning, with private landers, orbital scanners, and astronaut missions poised to peel back layers of mystery. Maybe you'll be the one to spot a new anomaly in telescope images or decode a pattern everyone else missed. Share your wildest theories in the comments. Did ancient civilizations gaze at these same structures? Could the moon's anomalies be natural or something more? The conversation starts now. And if your curiosity is hungry for more, hit subscribe. We're just scratching the surface of the universe's greatest puzzles. From Martian monoliths to underwater UFOs, the cosmos is packed with stories that defy explanation. Until next time, keep looking up. The next big discovery might be a blink away, hiding in plain sight on the silent, shimmering face